Department of Chemistry, Jamal Muhammad College. This e-content describes the fundamental differences between IR and Raman spectroscopy. At the end of this module, learners will be able to recall the basic concepts of both Raman and IR spectroscopy, differentiate one technique from the other, and understand how IR and Raman spectroscopy complement each other in chemical analysis. Now, I will explain one by one in detail. Infrared spectroscopy uses IR light radiation alone, while Raman spectroscopy uses laser light. The theory of IR spectroscopy is that it studies the interaction of IR light with molecules. During this interaction, molecules undergo changes in their vibrational energy levels due to absorption of energy. However, the theory of Raman spectroscopy is that it studies the interaction of monochromatic light with molecules. During this interaction, molecules undergo changes in their rotational vibrational energy levels due to inelastic scattering of light. IR works by absorption of radiation, whereas Raman works by scattering of radiation. In IR, vibrations are active if they change the dipole moment, whereas in Raman, they are active if they change polarizability. In IR, the allowed vibrational transitions follow the basic selection rule delta V equal to plus or minus 1. Delta V equal to change in vibrational quantum number. Here delta V equal to plus 1 means that this is due to absorption of energy. Molecules gain energy moving to a higher vibrational energy state to, for example, V0 to V1 and V1 to V2. Similarly, delta V is equal to minus 1 means that this is emission. Molecule loses energy moving to a lower vibrational energy state, for example, V1 to V0. Meanwhile, in Raman spectroscopy, the basic selection rule is delta V is equal to plus or minus 1 as well as delta J equal to plus or minus 2. We know that delta V is equal to change in vibrational quantum number, delta J is equal to change in rotational quantum number. IR gives strong signals for polar functional groups, while Raman highlights non-polar and symmetric vibrations. IR spectra appear as absorption bands, but Raman spectra appear as scattered intensity lights. KPR pellet is used as a solvent in IR spectroscopy. Water interferes strongly in IR, so aqueous samples are difficult to study. But Raman, water can easily study, that is, not disturb the Raman spectroscopy. Finally, I would like to conclude the above items in one point, that is, together, IR and Raman provide complementary information about molecular vibration and structure. Thank you very much.